Oh, we're recording. Okay, hello, welcome. If you passed blah blah blah. Okay, here we go, people. If you passed Module 5 Mastery Check number 2 with a 3 or a 4, you do not need to be doing this. If you did not, then you need to come back here and we need to go through this together. This is 5.2 Reteach. Make sure you have the worksheet doing it with me. Okay, so the first one wants us to find equivalent ratios by finding the basic ratio. When we simplify them, because just looking at these, none of these are the same. Looking at them, none of them are the same. But sometimes when we simplify them, we can see, oh, their basic is the same. It's just a repeated pattern of that one. So we need to simplify these using their greatest common factor. So I'm going to look at the smaller number. So I'm going to find 12. And I'm going to start thinking, can 12 nicely go into 16? No. Can 11? No. 10? No. 9? No. 8? Oh, 8 goes into 16, but it doesn't nicely go into 12. It's not a factor of it. 7? No. 6 goes into 12, but not 16. 5? No. 4? Ooh, yes, we need to divide both of these by 4. So we're going to write that we're dividing by 4. Now we're going to do the division. 4, 8, 12 goes in there 3 times. So this one is 3, and it goes into there 4 times. So this one, every time they had the scarecrows won 3, they lost 4. They won 3, they lost 4, and they did that 4 times. So we're going to keep going to see which ones are the same. So vampires, so can 9 go into 12 perfect? No. Can 8? No. 7? No. 6? Yes, but not into 9. 5? No. 4? No. 3? Yes. We're going to divide these both by 3. Their greatest common factor is 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. Ooh, our scarecrows and vampires are looking good. Let's see if there's any others. Make sure we didn't make a mistake here. So we're looking for a factor of 8 and 12. 8, no. 7, no. 6 goes in here, but not 8. 5, no. 4, yes. We want to divide both of these by 4. When we know our multiplication facts, this gets a lot easier. So if that's what you're stuck on, let's do some practice. So 8 divided by 4 is 2. 12 divided by 4 is 3. Not the same. And then 7 and 8. Can 7 go into 8? No. 6? No. 5? No. 4 goes into 8, but not into 7. 3? No. 2 goes into 8, not 7. So their only factor is 1. So these ones are already simplified. So the ones that had an equivalent amount of wins and losses were the scarecrows and the vampires. We can see that very easily here. We're proving it, not just circling two that we think. Okay, next up, Jason, Kendall, Nell, and Lennon are picking pumpkins. They're getting green or orange pumpkins in a set ratio. Oh, hey, look, we just did 12 and 16 right here. We know that we're going to divide it by 4, and it's going to equal 3/4. And then Kendall, 3 and 3 can both be divided by 3. So every time she gets 1 green pumpkin, she also got 1 orange pumpkin, 1 and 1, 1 and 1. She kept that ratio equal. Then Nell, can 6 go into 8? No. Can 5? No. 4? Yes, but not in 6. 3? No. 2? Oh, they're both even. They can both be divided by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. Oh, looking like Jason and Nell. Let's just check Lennon to make sure we're right. So 6 and 4 are both even. I know they can both be divided by 2. 6 divided by 2 is 3. Ooh, look there. Those are the same. But 4 divided by 2 is only 2. So it looks like Nell and Jason are the ones that have equivalent ratios. So every time we're finding their factor, dividing it to see who's the same. So So I expect to see what was your factor, what's your simplest ratio, your basic ratio. Okay, let's try making these equivalent ratio charts. So we always want to come and find, what do we know? We know there were, if you're going trick-or-treating, this person got 4 Reese's, then they got 12 Kit Kats every time. So they ended up having a ratio of 4 to 12, 4 to 12. So now we need to go back and find that basic one. Go back and find the 1. So if I go from 4 to 1, we had to divide, get smaller by 4. So I need to divide by 4. 12 divided by 4 is 3. Now this is the one we want to come back to every time. We're done with this one now. Go back to the beginning every single time. So how do I get from 1 to 6? That's pretty easy. Times by 6. So 3 times 6 is, I'm going to let you figure that out there. So now we're going from 3 to 9. 3, 6, 9. So times by 3. So now we need to do 1 times 3 right here. Then we have this one here. We need to go from 3 to 18. So 3, 6, 9, 12, 15, 18. That was 6 times. So now we need to go from here to here 6 times. And you might actually find 2 that were the same. Okay? All right, now we have cat lovers, we have dog lovers. So every time there are 2 people that like cats, we have 6 people that like dogs. So this is where we're starting, but we want to get back to that basic ratio. So how do I get from 2 to 1? So 2 to 1, we divided by 2. 2 divided by 2 is 1. So to get from here, 6 divided by 2 is 3. So there's 1 cat lover, 3 dog lovers. Now this is the one, right? I'm circling that basic ratio. I always want to come back to here. You can see everything connects to the beginning. So how do I get from 1 to 4? We times by 4. So I do the same thing to the other side. Now I'm going to ask myself, how do I get from 3 to 21? So I want you to figure that out. Write what it is, right? I write the problem and do the same thing to the other side. Write the problem. Now I'm figuring out, how do I get from 3 to 27? I'm making these rainbow connections. I won't sing the song for you. You're welcome. So I'm figuring out, how do I get from 3 to 27? And then I'm going to do the same thing on the other side. So make sure you're writing what is the problem you're doing to keep everything balanced and the same. So try those out, come get it checked off, and then you can go and look at your blue quiz to see if you can find the mistakes that you made.